Hello and welcome. This video is a high-level overview of OakGate Technology's Storage Verification Framework, or SVF. The OakGate system is comprised of two main components, the SVF controller and the SVF driver. The controller is a graphical console for the configuration and control of all testing and the analysis and display of test results. The controller typically runs on a Windows platform. The driver is the workhorse that interacts directly with the storage devices under test, as directed by the controller. The driver runs on the OakGate appliance. The controller and driver interact via IP sessions. You're currently looking at the SVF controller, and we see that several driver appliances are available. Note that the appliances are located on several different subnets. We're going to start up appliance OakGate V. We select the appliance from the list and click the Start button. Once the system is started, we'll expand the devices under test tree. We see that the appliance has one host bus adapter and that this HBA has 4 device ports. There are 2 SATA 2 hard disk drives attached to ports 0 and 1 and 2 serial attached SCSI or SAS solid state drives attached to ports 2 and 3. We're now going to initialize all of the ports. Select the first 2 ports, set the topology to SATA, set the size of the analyzer traffic capture buffer, apply the settings to both ports, select the next 2 ports, set the topology to SAS, set the size of the analyzer traffic capture buffer, and apply these settings to both ports. Now select all of the ports and initialize them. Notice that the labels turn green when the ports are initialized. Further expanding the devices under test tree, we can now see information about the devices that are connected to the ports. Note that you can resize the panels of the controller as needed. Clicking on the entries in the Devices Under Test tree provides additional information. Coming back to the controller, we'll activate the I/O Exerciser. I/O Exerciser provides a broad set of controls which allow for configuration of a wide range of test scenarios. The controls are grouped under a number of subtabs. We'll now set up and run a test with I/O Exerciser. The purpose of this test will be to see how the SAS drive reacts to LUN resets occurring amid ongoing reads and writes. First, we must select the SAS port that we want to configure the test for. Under the Top Level tab, set I/O traffic at 100%. This means 100% normal reads and writes. Check low-level timed air injection. This activates the use of timer settings on the low-level errors tab. Uncheck halt all traffic on fatal I/O errors. and halt LUN traffic on fatal I/O errors. This means that the SVF driver will continue to initiate reads and writes to the device even after an error occurs. Under the I/O traffic tab, set the queue depth to 32. Set the traffic pattern to 100% random I/O. Set read and write sizes to 4K bytes and check the fixed boxes. The fixed control means that all I/Os will be exactly the size specified. If the fixed control is not set, I/O sizes are randomly varied between 512 bytes and the specified size. We'll leave the read-write ratios set at 50-50. Now we'll open the Data Patterns section. Then set data patterns to 50% all Fs and 50% all As for I/O writes. Open up the I/O range section and set it to use only the middle third of the drive. Set the start range to 33% and set the range size to 33%. Under the Low-Level Errors tab, note that the settings in the first section, Low-Level I/O Errors, will be ignored because the Low-Level Errors slider under the top section tab is set to 0. Here. However, since the Low-Level Timed Error Injection box on the top level tab is checked, the rest of the controls on the Low-Level Errors tab are available. So we'll set the reset timer to a fixed setting of 5 seconds. Configuration of the test is now complete. To run the test, we must first select the LUN to be run. Note that the selection for configuration and selection for run are separate operations. Select the desired LUN entry and click the Select LUNs button. Now before we actually start the test, we want to activate the Analyzer tab. The Analyzer will show us real-time data during the test. To start the test, we go back to the I/O Exerciser tab. Now keep an eye on traffic state and I/O details. Then click Start Traffic. Notice traffic running, and notice that I/O warning shows up in the I/O details column. Now we'll stop the test and see what we have. Usually tests are run for a longer duration, but this quick test is for demonstration. We'll make an adjustment to the panel sizes, and then right-click on the I/O warning status and select Show Event Log. Now we resize the window so that we can see all the data. We see 3 warning entries. Each is a check condition, unit attention, bus device reset function occurred. Note that the timestamps of these entries are approximately 5 seconds apart. This corresponds to the 5-second setting in the LUN reset timer that we set up in I/O Exerciser. Per the SCSI spec, the target device is required to respond with this check condition to the first I/O command after a reset. Now we're going to close the window and rerun the test so that you can see the real-time data in the analyzer. We click the Start Traffic button and switch over to the Analyzer tab. The lower right panel shows commands and responses as they occur. The task management count represents the device's acknowledgments of the LUN reset commands. The SCSI check count represents the check condition responses resulting from the LUN resets. Now back to the I/O Exerciser to stop traffic. From here, let's open the event log again. Note again that there are 3 warning messages. This time, we select the first warning message, right-click, select Show in Analyzer, and then close the event log window. Note here that there are 3 task management frames and 3 SCSI check frames, again correlating to the 3 resets that have occurred. Up above is the analyzer's task traffic viewer with the check condition response highlighted. Since this is a response frame, let's go to the matching command frame. We do this using the frame navigation buttons. We click the command button and we see the corresponding command frame. Scrolling a bit, we see this is the first I/O command after a reset condition. So this command response pair is showing the SCSI spec in action. To continue this analysis, we know that the LUN reset is a task management function. So we right-click on the task management and select Find Previous, meaning immediately previous to our current location in the traffic buffer. Here we find the task management response frame. Once again, we'll use the frame navigation command button to find the command that matches this response. And there we are, the LUN reset command. Thank you for watching this video. For further information, please contact OakGate Technology. We look forward to hearing from you.